Hello everyone. In the lecture discussion of vector calculus, in the previous discussion we were interacting on the concept divergence. In this discussion we will discuss more on divergence, that is we are going to discuss about the examples in divergence. So, in this particular concept, first let us discuss about 2D divergence example. In a 2D vector field, consider a flow pattern around a sink of a source where flux diverges radially outward or inward, demonstrating divergence. This is one example of 2D divergence. As a 3D divergence example, you can talk about let us imagine a 3D vector field representing the flow of a fluid, regions where the flow spreads out, showing divergence that can be observed near sources or sinks. So, you can see there you have 3 dimensions because you are talking about the flow spreads. So, there comes the concept of 3 dimensions. So, even divergence can be applied in the area of 3 dimension. So, as the next application we can work with applications in electromagnetism. In electromagnetism, divergence of the electric field is related to the charge distribution, and the divergence of the magnetic field is tied to the absence of magnetic monopoles. So, this is a very important application of divergence when it comes to electromagnetism. So, in this discussion we can go further into visualization of divergence, that is we can further think about the visualization of divergence. In fluid dynamics we can see how fluid illustrates the divergence in 2D and 3D spaces. That is one application, one best concept of visualization of divergence. In the next level, in fluid sources, we can discover visual representations of divergence near field sources. In the next level, geometric interpretation, where we can explore geometric shapes that illustrate divergence concepts. All these things can be visually seen. So, visualization of divergence is very important to understand the concepts, in measuring the magnitude of vector fields in a given point. So, you can see the various scenarios in divergence, that is you can see we can find positive divergence, we can find negative divergence and also zero divergence. These are some areas of divergence where we work in order to understand the concept of divergence in applications of engineering. As a conclusion, I could say that in engineering we can use the vector calculus concepts where the vector field is worked with calculus. Calculus is the concept of differential application and also integration. So, we use the concept of differentiation and integration, which are mathematical concepts, in order to solve, in order to mathematically model the real time scenario. For example, we saw divergence is more useful in fluid dynamics. So, such engineering area can be taken for consideration. Then the pain points of these scenarios, real time problems can be analyzed. We can create mathematical equations, that is called mathematical modeling, by which we can understand and also by using the laws, physical laws, we can create mathematical models and we can use mathematical methodologies. We have various mathematical methodologies to solve differential equations, and by that we can do analysis, we can do results, and we can have some interpretations, so that we can have beautiful outcomes, so which is more useful for the society. So in this regard, we can understand, we have to master in vector calculus to apply those ideas into various engineering fields. Not only in fluid dynamics, we can apply it in various areas of engineering. Thank you.